Okay, we are doing 4-5B first. It's very short. I have 2 quick examples, and then we're done with that, and we'll move on to the 4-6 stuff. But 4-5B is all about equilateral triangles. So the first thing you need to know about this is if a triangle is equilateral, what does it mean to be equilateral?
All 3 sides are equal.
All 3 sides equal. Okay, so if a triangle is equilateral, then it will be equiangular. Do you know what it means to be equiangular? All 3 angles equal. Okay, so here's the setup. If this is true, okay, if I know that, then the red is true also, right? If it's equilateral, then it's equiangular. The converse of that is also true. So what if I have this triangle and all I know is the 3 angles are equal? Well, if the 3 angles are equal, then it will also be true that the 3 sides are equal. So if it's equilateral, it's equiangular. If it's equiangular, it's equilateral. In other words, you cannot have an equilateral triangle that doesn't have 3 congruent angles, and you cannot have an equiangular triangle that doesn't have 3 congruent sides, okay? So with that in mind, this is like example 3 in the book. And here's what it looks like. All right, let's say we're going to find the measure of angle A, the measure of angle B, and the measure of angle ADC. Okay. First thing I want to know is, can you tell me what lowercase a would be? You can. Because if we know it's congruent to everything else, then those are all A's, right? It's 60, right. I can say A plus A plus A, or 3 times A, has to equal a triangle, which is 180. So if I divide by 3, then A is going to be 60, okay? So every equilateral triangle will have 3 60-degree angles every single time. That means every individual angle that you see here is 60 degrees. So the measure of angle A, which would be this one down here, is what? 60 degrees. The measure of angle B is 60 degrees. So if you look, the measure of angle ADC has what as its vertex? D. It's always that middle letter that we're looking for. So ADC is this angle. And I'll tell you right now, for some reason on this next quiz, people see 3 letters and they start adding all the angles together. Don't add a bunch of angles together. Don't add angle A plus angle D plus angle C. That's not what angle ADC is. Angle ADC has a vertex of D that started at A and went to C. So I'm looking, when I say angle ADC, I'm looking for this angle. Okay? What would that angle be? 120. You have 2 of these little A angles, right? So you would do 60 plus 60, or the measure of angle ADC is 120. Do you all see that? Don't take angle A plus angle D plus angle C, okay? Just D as the vertex. What is that angle? Okay, so that's the first example. Questions on that? Okay, second example really isn't new. It's more just what we did yesterday. It's isosceles, because there's really not much to talk about with equilaterals. We should just lump them together, but try to save you a little time, I suppose. Let's say we have this triangle, and this is 36 degrees, and I want to know the measure of angle A. A little bit of recap here. What do you do? What do you know in this triangle? What can you tell me about its angles?
A and C are congruent.
You know that A and C are congruent because it's isosceles, right? So the angles opposite the sides have to be the same. So if A and C are congruent, we can call those whatever we want. If we call it X, then they're both X, right? So we would say 2X plus 36 equals 180. Take away that 36, so 2X equals 144, and then divide by 2. So X would have to be 72 degrees. Okay? What if I gave it to you a slightly different way? So now I told you this was 76, and I want to know A and B. So instead of giving you the vertex angle, I'm giving you a base angle. What do you do differently? What's A? 76, right? These two have to be the same. So A would be 76. And then what would B be?
180 minus 152.
Right. So you're going to take away the two 76s, right? So it'd be 76 plus 76 plus B. That has to add up to 180. So if we take away 152, then B would have to be 28. Okay? Good on that?